Okay, finishing off part C to this question. So how long will it take for Barry's investment to triple? So the investment has to triple, so we know that the amount, the end amount is going to be 15,000. All right, so we know from above, from our base equation, that this is what we're looking for. So 15,000 equals 5,000 bracket 1.02 to the exponent 4t. You can go to the calculator at this point. However, this calculator gets a little wonky. So what I always tell people to do, it's a good habit to get into dividing by the initial amount if you know it. And the calculator then, higher percentage chance the calculator is going to work. Because like I said, it's not perfect technology here. Cell phones have more probably computing power than the calculator there. So anyhow, we're going to let y1 equal 3 and y2 equal to 1.02. So exact same process as you did yesterday. Now you bring up that calculator and you enter your two equations. So a 3 and a 1.02 to the exponent. And I'm going to put it in brackets just to be careful here. Looking at the window, my y value isn't going to go above 3. So y max, I'm going to change to a 5. And if I'm looking at, if I want to predict what it's going to be, I know that from B part, 10 years it was 11,000. So it's got to go more than 10 years. So let's go out to 20 years and see how close we are here. So there is the value 3. Here's our curve. Is it going to reach it? Yep, looks good. So there we go. We have a point of intersection right there. So finding your point of intersection, same as what you did yesterday. Point of intersection is 13.9. So therefore, point of intersection is 13.9 and 3. So that would mean that it will take 14 years for Barry's investment to triple. All right. And I'm going to go 14 because 13.9, you're probably going to leave it for the full year anyway, so just as easy to say 14 years, it's going to triple. Next example, Greg has a pet ant farm. Starts the colony with 25 ants. So I see the word starts and 25 ants. He's measured the growth rate to be 18% per year. So what that tells me off the get-go is that A, it's not a financial question. So my initial value will be an A, and it looks like it's 25 ants. I know the growth rate. The growth rate is my B value. It's 100% of last year's and 18% of this year's, so 1.18. Okay, so we're going to end up using this formula. I guess I can go ahead and answer A part here. So create a model. Because it's a yearly thing, we're going to use the mathematical model that we talked about, AB to the exponent x. Anytime you have a percentage given to you for the base, then the odds are you're going to use the corresponding mathematical formula. So it ends up looking like this, 25, 1.18 to the exponent x. So there is the model we're going to use. B part then, determine how many ants we'll have in 5 years. So we've been given x equals 5 years. So this is just plugging into the equation, making sure that you can use the calculator to punch in an exponential expression. So I'll bring that up. And 25 multiplied by 1.18 exponent 5. We've got about 57. So 57.2. So therefore, in 5 years, Greg will have 57 ants. Don't put the 0.2 in. You can go 58. I don't care, 57, 58. Just don't put part of an ant in. It doesn't make, when you read it, it sounds silly. You got to have a whole ant. So 57 ants or 58 ants. How long is it to get to 1,000? So C part. we know the total is going to be 1,000 ants. So using our model, 1,000 would equal 25, 1.18 to the x. So we're looking for an exponent. It means we're going to have to use the graphing calculator. Divide both sides by 25. And we end up with 40 equals 1.18 to the exponent x. Graphing calculator can handle that a little bit better than the 1,000, or it's more likely to be able to handle it. 1.18 to the x. So now, same process that we practiced yesterday. You need to be able to pull the calculator up. You need to be able to enter the two equations in and find that point of intersection. 1.18 exponent x. So the window, x max, well, let's see if it's going to be 20 years for it to happen. Y max, I have to go up to at least 50 here because the one y value is 40. So there's the y equals 40 line. When does my curve get there? Here we go. Keep going, keep going, keep going. Oh, it's off the page. So I got to go back to the window, and I'm going to extend it out to 30, the x max. Close. Here we go. It's climbing. There we go. There's the intersection point. So your intersection point's right there. Find that point of intersection. And we get it to be, so it's going to be about 22, 22.28. So therefore, point of intersection, 22.8 and 40. So therefore, it will take 23 years for Greg to have 1,000 ants. They must be pretty expensive for important ants. Okay. Moving along to the next example here. So in the next example, Owen has borrowed 150 grams of radioactive material. And I can't stress enough, this is not recommended activity to be following or performing. And he did it from a nearby nuclear facility and stashed it in his closet. If the material has a half-life of 80 days, answer the following. So a couple of things that stand out, okay, other than the fact that Owen's doing something that's completely illegal. 150 grams of radioactive material. So that's an initial amount for us. Because it's not money, the initial amount must be A. So 150 grams. We know that we have two pieces of information here. Half-life and 80 days. Half-life tells us the base, our B value. So B is going to be 1/2. The 80 days tells us how long it takes for half-life to occur. So we have our T value. So it dictates, we know now what formula we're going to use, and we got to make sure everything's in grams and days. So A part, I know the equation. I'm going to use the one from the natural sciences, which is x over t. So the model we're going to use, f of x equals 150 bracket 1/2 x over 80. So there is our answer to A. That's the model for this situation. Determine how much material is left after 120 days. So we know x is 120 days. So we are simply, again, can you use a calculator to calculate an exponential expression? The trick there is the exponent has a fraction, so just be careful. So pulling that calculator up and going to calculation mode. I'm going to put the 1 divided by 2 inside the brackets. Exponent, bracket, 120 divided by 80, bracket, 53. So it's equal to 53 grams. So therefore, after 120 days, if Owen's still alive, there will be 53 grams of material. So the nuclear material, it actually does decompose and right in front of you. And if you're watching it that close, it's not really a good thing, but the mass of the material will physically decrease. Final part here, C part, determine how long it will take for 1 gram of material to be left. So we have a total. So f of x equals 1 gram. So using our model, we end up with this. Now here is a circumstance where I go against what I was telling people to do. In this case, f of x is 1. If I divide by 150, I get into fractions. I really don't care for the fractions. So in this case, I'm just going to leave it as is. So I'm going to let y1 equal 1. y2 then will be 150, 1/2 to the x over 80. So now you bring up your graphing calculator to put those two equations in order to find the intersection point. So 1, and clear that, 150 times 1 divided by 2, exponent x divided by 80. Okay, the window. I know that the y value is going to be only going up to 1, so I'm going to change the min to 0 and 1 just because it's really small values. How much time is it going to take? Well, in the previous question, 120 days, it went 53 grams, so it went down a third. So let's start with 100 years and see what happens here. So what happens after 100 years? So I graph it. So there's my line y equals 1. And the curve doesn't even show up, so that means I did not go far enough. So I said before, go up by multiples of 10. So I'm going to go up to 1,000 now, see if we can find that curve. And there he is. So our point of intersection is right here at the top of the screen. So the calculator will still handle that. Hitting enter 3 times, we find it is 578. So therefore, point of intersection is 538 and 1. So therefore, after 538 years, there will be only 1 gram left. All right. So a couple of things to keep in mind when you're doing these questions. Make sure you do your therefore statements, because in the application question, I'm looking for the therefore statements. Okay. Make sure you tell me what information you're plugging in. Okay. There is another example, but it's a money example, so it's very similar to the first one. I'll let you give it a try yourself. There's the homework for this section. There's about 12 questions. Please make sure you try each one because there's a twist or something different with each one. If you have any problems, you know where to find me, and good luck.